All right, we're going to do maybe just one, maybe several videos of how we can employ systems of linear equations to solve problems that we're encountered with. Some of these are a little bit more realistic than others, but I'm going to try to do a variety of different types. First one has been tagged here as a geometry problem. It says that the length of a rectangle is 3 centimeters more than twice its width. If the perimeter of the rectangle is 36, then what are the dimensions of the rectangle? Definitely starts by drawing us a picture of a rectangle, and it says the length is 3 centimeters more than twice the width. So if that's the width, then the length is 3 centimeters more than twice that. That's what our rectangle would look like, which clearly means those dimensions are true as well. And it says that if the perimeter of the rectangle is 36, then what are the dimensions? This is the way I set it up. It's not going to end up as a system of equations, but I'll show you how it would. In fact, let's do that. The length is 3 centimeters more than twice the width. And normally for perimeter of a rectangle, that's 2 lengths and 2 widths. That perimeter is equal to 36. And we could solve this in a number of different ways here. It already says L equals, so it's set up for a substitution. So we could do 2 times the other name for L, which is 3 plus 2W, because the first equation there says that L is the same thing as 3 plus 2W, plus another 2W is equal to 36. So that looks like a 6 plus 4W plus 2W is 36. So 6 plus 6W is 36, 6W is 6, or is 30, sorry. I'm going to subtract the 6 from both sides, and so the W would be 5, that's the width is 5. And if we substitute that 5 into the top equation, again it says the length is 3 plus 2 times whatever the width is, and we now know that the width is 5, so that's 3 plus 10, the length would have to be 13. Double checking that, if I wanted to, 2 lengths plus 2 widths, 26 plus 10 is 36, fits the definition of what was on there. Definitely helps sometimes to have a picture going on when you can, especially if it's a geometry related problem. All right, this one is tagged as a mixture problem. The chemist wants to combine 20% alcohol solution with 60% solution to form 200 milliliters of a 45% solution. How much of each solution should be used in the mixture? So, this question, how much of each solution, that's referring to the 20% solution and the 60% solution. We're going to define our variables. And we'll say that X is the milliliters of 20% solution, and Y will be the milliliters of 60% solution. And the first thing that we see from this is we've got this statement. We want 200 milliliters to begin with. Well, all of those milliliters are going to come from a combination of these two things. And so X stands for milliliters of the one, and if I add that onto the milliliters of the other, then this statement up here says that I should end up with 200 total milliliters. So there's one of my equations. The other equation here, we're going to focus on how much actual alcohol is in these things. So using the percentages here, we've got 20% of the milliliters of the 20% solution are going to be pure alcohol. And if we add that on to 60% of the milliliters of the 60% solution are going to be pure alcohol, then this is an equation about how much pure alcohol is going to be in this mixture. The rest of it's water, right? And we want a 45% solution. We want 45% of the total solution, of which there are 200 milliliters. Okay. That's going to be how much total alcohol we want in the solution. This represents everything of where it's coming from. So these are our two equations. We could solve this in a couple of different ways. If you don't like the decimals that are in here, we could definitely multiply everything in this bottom equation by 100 and get that 20x plus 60y is equal to 45 times 200. And then I could take my top equation. If I took the top equation, multiplied everything by negative 20, I could get a negative 20x minus 20y is equal to negative 20 times 200, which is negative 4,000. Okay. My 45 times 200 here feels like about 9,000. Let me double check that. Yep. Okay, so this is 9,000. And if I add those two equations together, my x's are going to go away. I'm going to be left with 40 y's are equal to 5,000. And so if I divide both sides by 40, I'm going to get 125. That was y. Y, remember, I defined to be my milliliters of the 60% solution. So I have 125 milliliters of the 60% solution, which means the other 75, since I know they have to combine to give me 200, the other 75 would be the milliliters of the 20% solution. Okay? So I need 75 milliliters of this, and 125 milliliters of the 60% solution. If I mix those together, I should end up with exactly 200 milliliters, obviously, and concentration is going to be 45% there. All right. This one is labeled as an investment problem. So Miguel has $3,000 more invested in a mutual fund paying 5% interest than in a savings account. Okay, so that pays 3%. If he received $310 in interest for 1 year, how much did he have invested in the two accounts? So how much did he have invested in the two accounts? That tells me what my variables need to be. I need one variable to represent the money invested in the mutual fund. And my y will be the money in the savings account. Now, what it tells me is that he has $3,000 more invested in the mutual fund than in the savings account. So that says the mutual fund, if I take that, and that will be equal to then the amount in the savings account, plus the savings account would have to have $3,000 more to be the same as we have invested in the mutual fund. Okay, so that's one of our equations. The other equation has to do with this interest number. Okay, where does that interest come from? Well, he has earnings from his different investments here, and so the money he has invested in the mutual fund pays 5% interest. So he gets 5% interest times the amount of money he has in the mutual fund. Okay. Plus, he earns interest on the savings account, but that's only 3% interest on the savings account. And those two things together account for, so this 0.05x is interest earned from mutual fund, that's dollars. 0.03y is interest earned from the savings account, that's also dollars, and that's where this $310 came from that he earned in that 1 year. So here are my two equations. The top one is set up to make a substitution. Okay, so I can do 0.05 times, following that substitution up there, it says x is the same thing as y plus 3,000. Plus 0.03y is equal to $310. Do a little distributive property over here. I get a 0.05y plus, it's going to be about 60 there, 3,000 times 0.05. If this weren't a video, I wouldn't be double checking myself. Ooh, good thing I did. Okay, that's 150 plus 0.03y is equal to 310. Can combine some like terms here. That's 0.08y. Subtract 150 from both sides, and I'm going to be left with 160. And then divide by 0.08. And y is going to be 160 divided by 0.08. That is $2,000. Okay, so y is 2,000. Y stood for the amount of money in the savings account. Okay, so his savings account money, he has $2,000 there, and x is y plus 3,000. So 3,000 onto that means that he here has $5,000 invested in the mutual fund. All right, again, defining the variables, keeping track of that kind of thing. I think I have one more to do here. This is called a motion problem. That's how it was labeled. The boat traveled 36 miles up a river in 3 hours. Returning downstream, the boat took 2 hours. What is the boat's rate in still water, and what is the rate of the river's current? So it asked me those two things. Those then need to be by variables. I've got the rate in still water and the rate of the river's current. So I'll let my x be the rate in still water. What happens with a boat is it is very affected by the current. When it's going with the current, the rate increases at the same rate as the current. And then it's subtracted from it otherwise. So the other important thing in these kinds of problems, we've got rates and we've got times, and we'll break out our rate times time is equal to distance, right? If you travel 60 miles an hour for 3 hours, you've gone 180 miles. So for this, we have a fixed distance. And so we're going to make two equations, one for the trip where he is going upstream, so he's fighting the current, okay? And the rate at which he is fighting the current is going to be the rate of the boat in still water minus the rate of the current. So the current takes away from the speed that he's able to travel, and that is times a time that we don't know and we're not actually asked for in this. We'll see how to deal with that here in a little bit. And that is equal to a distance. And the distance that the boat traveled is 36 miles. Oops. Figure out what's going on there.